In this video, we'll be covering Chapter 10, Section 1 on the ellipse. The ellipse will also include the conic section for the circle, so these two will be in this section. 10.2 will be on the hyperbola and 10.3 will be the parabola. On this section, it's basically giving us the formulas when the ellipse is graphed in the origin at 0, 0. The definition of an ellipse is where all set of points in the plane such that the sum of the difference between the two fixed points is constant. So in other words, here we have these points called the focus, here and here. When we connect the distance between the foci and the edge of the ellipse, this distance will remain the same. So the distance that I just drew would be the same as if the distance were here. It's the same as if the distance were here, and so forth. So all of these distances are the same. The line segment with the end points at the vertices right here and right here is going to be called our major axis. So if you notice here, this is the longer side, which is called our major axis. So here we have a major axis that is horizontal. So our other two main points here and here is going to be called our minor points. If you notice our equations here, A will always be bigger than B. A and B are both going to be positive numbers. Now I want you to notice the difference between the major axis as being the x-axis and the major axis here being the y. Notice that you have an x squared, here you have a plus, a y squared, and they're both equal to 1. So the difference is where our A is. If you notice on this set of equation, the A is located underneath the x. This means that the x-axis is going to be our major axis. When the A is underneath the y, that means our y-axis is going to be the major axis. If you notice on your formula sheet, you are not given the pictures that are given here. Okay. The other thing you should notice about the formula sheet is that this set of equations is slightly different. Notice that here you have a minus h and here you have a minus k. Over here you don't have that. The reason being is that these set of equations are going to be assumed at the origin. Remember, your center is going to be 0 for h and 0 for k. So they do not include those points on this formula. What I ended up doing was giving you the formulas as if it is not centered at the origin, but they will still work regardless. So here we have the center at 0, 0 for both of these. Our foci is going to depend if our major axis is on the x or on the y. So will the vertices, and so will the minor axis points. Let's go ahead and graph some of these. Number 1 says, graph the ellipse and identify the center, the foci, and the vertices. I'll be using the formula sheet that I've provided for your exam. The other thing I recommend in this unit is having a clear post-it note, so we can cover up the set of equations we don't use. Okay, let's go ahead and start with the first one. It shows here that we have an h of 0, since there's no number attached to the x, h is 0, and also our k will be 0 since there's no number attached to our y. The next thing you want to do is go ahead and look for your larger number. As we can see here, 25 is larger than 4, and then our major axis is going to be horizontal. So we can say here, 25, it's underneath the x, which means that this is going to have a major horizontal axis. First thing I'm going to do is go ahead and label my center. So my center here will be 0, 0. That's going to be that point right there. Then it says to identify the foci and the vertices. Let's go ahead and look at our set of equations. Since we've already identified that we have a horizontal axis, we can go ahead and cover up the vertical axis equations. If you're taking the test in class, I will normally provide you with a sticky. Let's go ahead and finish this one. We know that our a squared is going to be equal to 25, so I'm going to put a squared is equal to 25, which means a is equal to 5. B squared is going to be equal to 4. So here I can say b is equal to 2. So the next thing we want to do is find our foci, and here is our foci information. It has a note that says c squared is equal to a squared minus b squared. So what we're going to be doing is finding what c squared is. So I'm rewriting the equation, and now I'm just going to plug things in. 25 minus 4 is equal to 21. So this means c is going to be equal to the square root of 21. To find the foci, we're going to be using our equations. We already stated that h is going to be 0 and k will be 0. So all I'm doing is basically adding c. So our foci is going to be 0 plus c, which is the square root of 21, comma k, which is 0, and h minus c, so 0 minus the square root of 21, comma 0. This is going to be our foci. For graphing purposes, I'm going to go ahead and put this in my calculator and get an approximation. You never want to use the approximation on your answer. You always want to use the exact formula. So here it'll be approximately 4.6. In order to find our vertices, you can notice on the equations we need to know what a is. We know what h is, we know what k is, and we now know what a is as listed here. Let's go ahead and find our vertices. Vertices is going to be h, which is 0, plus a. a is 5, so I have 5, comma 0. That's what my k is. And h, which is 0, minus 5, comma 0. So here I have my two vertices. Now we're going to go ahead and graph. Okay. So basically I started with the center, which was here. One of the easiest ways that I can do this is I normally just look underneath the variable x and I take the square root of that number. Here the square root of 25 is 5, so I'm going to go 5 units in the x direction. That means I'm going to go 5 forward, 1, 2, 3, 4, 5, that's my vertice, and I'm also going to go 5 back from the center, 1, 2, 3, 4, 5. So these are going to be my vertice points. C is going to be where our foci is. So I'm just going to label that F. Now these are the only things that we needed to identify, but notice we can't graph this unless we know what our B is. Remember our B squared is equal to 4, which is underneath the Y. So the square root of 4 is 2, and I'm going to go 2 in the Y direction. So from the center I'm going up 2, and from the center I'm going down 2. Now that I have our major and minor vertice points, I'm going to go ahead and draw my ellipse. It will look something like that. Number 2. Number 2 says to graph the ellipse and identify the center, the foci, and the vertice. It's going to be very similar to the problem we just did. However, if you notice this here, it's not in the equation that we need it to be. We always want our equations to be in a standard form, which looks either like this or like this. So our equations have to equal 1. Since these don't equal 1, I'm just going to go ahead and make it equal 1 by dividing everything by 441. Use your calculator to simplify. I'm going to go ahead and start with the first one. 49 divided by 441 will get me this, and then I can go ahead and translate that back into a fraction. So this is going to be x squared over 9 plus, and then now I'm going to do 9 divided by 441. Turn it back into a fraction, and I get 1 over 49. Don't forget the y squared, so I'm going to have y squared over 49 is equal to 1. Now I can go ahead and identify our center. Notice that we still don't have a number attached to the x or to the y, so our center here is going to be 0, 0. That means our h is 0 and our k is 0. Our a squared is going to be always the larger number. Since 49 is the larger number in this case, we would know that a is equal to 7. Our b squared is going to be the smaller number, so that will be b is equal to 3. The next thing I'm going to do is go ahead and find our foci. But remember, when we're finding our foci, we need to know what the value of c is. So I'm going to go ahead and solve for c here. C squared equals a squared minus b squared. So c squared is going to be equal to 49 minus 9, which means c squared is equal to 40. That means c is equal to the square root of 40. Don't leave your answer in this form. If we can simplify it, we should. Remember, 40 is 4 times 10. So I can take the square root of these individually, and then I get 2 square root of 10. So c is equal to 2 square root of 10. This is going to be our simplified form. This is not simplified. We always want to write our answers in simplified form. The next thing I'm going to do is determine which set of equations that I need to use. If you notice here, our a squared is going to be the larger number, which indicates it's underneath our y. So we need to cover up our major axis that is horizontal. Now I can use the foci formulas for our major axis that is vertical. So our foci is going to be our h, which is 0, k, which is 0, plus c. And remember, c is this 2 square root of 10. And let's use the other formula, which is h is 0, k is 0, minus c. So we have minus 2 square root of 10. This will be our foci. For our vertices, we'll be using this equation here. So I'm going to go ahead and put that vertices. We're going to just plug in our formula. H is 0, K is 0, and A is going to be 7. And 0, negative 7. Let's go ahead and graph this ellipse. Our center is 0, 0. We're going to use 3 in the x direction. So I'm going to go 1, 2, 3 forward and 1, 2, 3 back. 7 is going to be in the y direction. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So when we graph our ellipse, it's going to be a major axis that is vertical. It will look something like that. Okay. Typically here we do not need to graph our foci, but I'm going to go ahead and do that just to make sure that it makes sense. So I need to find what the distance of 2 square root of 10 is. If you prefer, you can use the square root of 40 and it will give you the same answer. Here we have 6.3. So that means the foci is going to be along the major axis and it's going to be 6.3 units away from the center. So if this was 7, 6.3 would be about right there, and negative 6.3 would be about right there. Now we have our final graph. On this page, you'll see the information that you do get on your reference sheet. Notice that this one doesn't assume that the center is at 0, 0, but now it's assumed at h and k. These are the formulas you're given. You do not have the graphs. Those you need to know. If you notice up here at the very top, it's saying recall that the equation with a circle is centered at hk with r radius. Now, how are these two the same? Well, like what we said before, remember in this case A is bigger and B is smaller. But what if A and B are equal to each other? If A and B are equal to each other, then that means that the distance here is exactly the same as the distance here. And in that case, that gives us a perfect circle. So we don't have it in fractions like this or equal to 1. What we do instead is show that that equation is equal to r squared. So our radius is going to be the same for x as it is for our y. Okay, let's go ahead and graph one that's not centered at 0, 0. So the first thing I want to do is go ahead and use our formulas and identify the center. Now in this case, you can see that the center is not at 0, 0 because you have a number attached to your x and you have a number attached to your y. If you notice the equations here and here, you can see that a negative sign is associated with our equation. See that I have a positive sign, which means that our h is going to be associated with a negative 2. So our center is at negative 2, comma. Notice that this one has a negative already. That's the negative that's part of the equation. So our k in this case is just going to be 3. So our center is going to be at negative 2, 3. H is equal to negative 2. K in this case is 3. Now our a squared is always going to be the bigger number. So here I have a 16. That's bigger than 9. So a squared is equal to 16, which means a is equal to 4. Our b squared is equal to 9, which means our b is equal to 3. In order to find our foci, remember we need to find the value of c. Okay. Let's go ahead and do that. I don't need to know which equations it is yet because all I'm doing is solving for c. We'll use the note here. So our c squared is equal to a squared minus b squared. A squared is 16 minus b squared, which is 9. So here I get c squared is equal to 7. So c is equal to the square root of 7. Remember, leave it in this form, but if you do want to find out what that value is for graphing purposes, go ahead and put that approximation. I'm going to do the square root of 7. It's approximately 2.6. Let's go ahead and figure out what our equation is. Since our a squared is 16, which is the bigger number, we have a major axis that is horizontal. So we'll be using these set of equations. It's easy to just cover up the other set. Let's look for our foci, which is this equation here. Our foci, which I'm going to denounce as an F from now on, is going to be our h. Remember, our h is negative 2. Plus c, which is the square root of 7, comma k. K is equal to 3. And h, which is negative 2, minus the square root of 7, comma 3. Now, some of you might want to go and try and add these two. These are not terms that can be combined. This is a rational term. This is an irrational term, very similar to pi. So when we try to add these, we really can't. We can just leave it in this form. Rational numbers first, irrational numbers at the end. Now let's go ahead and find our vertices. Our vertices are going to follow these sets of equations. So I'm going to have v, h, which is negative 2, plus a, which is 4. Comma 3. Notice on this one you have two rational numbers. So we can say negative 2 plus 4 is the same thing as 2. So here I have 2, 3, and h, which is negative 2, minus 4, which is a, comma 3. Then use your calculator if you need to, but here you'll get negative 6, 3. So these are going to be our two vertices. Let's go ahead and graph this. First, start with your center. Negative 2, 1, 2, 3. 1, 2, 3. Here's our main point. Now, this is why I like to do it this way. If I'm on my center and I look at the bottom, I can see that the square root of 16 is 4, which means that from the center, I want to go in the x direction, plus 4 and minus 4. So from here, I'm going to go 1, 2, 3, 4. And then from the center, 1, 2, 3, 4 back. I like to do this because what I'm expecting is our vertices to line up in these points. And I go 2, 3, I'm going forward 2 and up 3. Well, that point matches the point that we got mathematically, so I know I'm on the right track. Let's look at the other one. -6. Well, let's try it. 1, 2, 3, 4, 5, 6 going back. 1, 2, 3 going up. This one also matches. So we know that our math is correct. Now, for the y direction, you're going to take the square root of the number underneath it. So the square root of 9 is 3. So from the center, I'm going up 3, and I'm going down 3. Now I can connect the outside dots, and this is going to be my ellipse. And there you go. Let's go ahead and make sure our minor axes are exactly where they need to be as well. Okay. Again, using your formulas, you see that our minor axis is going to be in H. Let me go ahead and put minor here. Our H, which is -2, goes in the front. And K plus B. K is 3, B is 3. So I'm going to put 3 plus 3. Okay. This is going to come out to -2, 6. The other minor axis point will be at H, which is still -2, comma, and then here it says K, which is 3, minus B, which is 3. So 3 minus 3, and that reduces to -2, comma, 0. So let's check these. So we have -2, go back 2 and up 6. 1, 2, 3, 4, 5, 6. Here's our minor point. And then -2, 1, 2, 0. So here's our other minor point. So I know that this graph is correct. Number 4 says to write the equation of the ellipse in standard form, and we're going to again identify the center, the foci, and the vertices. Now, when you see an equation similar to this, we want to do what is called completing the squares. Completing the squares is something that you should have done in college algebra, but I'm going to go ahead and review that now. So, first thing you want to do in this case is combine our like terms. So we have an x squared and we have an x. We have a y squared and we have a y. So we're going to group them accordingly. Notice that this number 9 here, we're not going to group it with the group of x or with the group of y. Instead, we're going to move this over to the other side of the equal sign. So let's go ahead and start by doing that. We're going to have 9x squared plus 18x, plus we're going to add some number. Okay. Now we're going to do plus 5y squared minus 30y plus some number. Here's where I'm going to go ahead and set it to equal sign, and I'm moving the 9 over to the other side. So it'll become a -9. Notice that I have 2 blanks here. Since I'm adding 2 additional numbers in these blanks, that means I have to add 2 additional numbers on the other side of the equal sign. Okay, so let's go ahead and complete the squares. Now, what I'm going to do first is go ahead and combine all of these terms together. I never want to do completing the squares when you have a coefficient other than 1. So in this particular case, what we need to do is factor out the 9. So if I factor out the 9, I'm going to have a set of parentheses that include x squared plus 2x plus some number. Okay. So if I distribute this 9 back in, I get the exact same thing that I have up there. I'm going to do the same thing for my y. So I'm going to say plus 5 parentheses y squared minus 6y plus some number. This is going to stay as it is. So minus 9 plus something and then plus something else. The next thing I'm going to do is I'm going to take the middle term. In this case, that's a 2. And I'm always going to include the sign. So it's positive. I don't need to write positive. And then we're going to divide that by 2. This is going to be equal to 1. So I'm going to put a plus 1 here. And then I'm going to complete the squares, meaning I have to square something as well. So once I take this number 1 and I square it, I still get a 1. Well, this is the number that goes in our first blank right here. Okay. So be careful. You don't want to put a 1 in this blank because remember we're multiplying this 1 with a 9. So we're going to do 1 times 9. That is 9. This 9 actually goes in the first blank here. We're going to do the same thing here. I'm going to take the middle term, which is negative 6, divide that by 2. That gets me a negative 3. You're going to square it. That gets me a 9. That goes in our first box. That 9 goes in our first blank. But remember, we're doing 9 times 5, which means on this side, we're actually adding 45. So I need to add 45 here. That goes right there. Okay. All right, now, in order to go to the next step, what we're going to do is drop the 9 straight down. And then, I don't know if you noticed, but I put parentheses around this section and this section. And if you can see, there's a slight little gap in front. This is to indicate that I need to include a variable there. And the variable I choose will be the variable that I'm dealing with. So in this case, I have an x. I just want to put an x value right in front of the plus 1. So I'm going to say x plus 1 squared. Then I'm going to bring down my 5 plus 5. And I'm going to again use the little parentheses here as a tool. Here my variable is y, so I'm going to have y minus 3 squared. All of that, and then use your calculator. Well, here the negative 9 and the positive 9 will cancel out, leaving me with just 45. Notice that our coefficients here and here are different. That means that this is not a circle. So what I'm going to do is set this equation equal to 1. In order to do that, I need to divide the entire thing by 45. Use your calculator to help you simplify. Here you should get x plus 1 squared divided by 5 plus y minus 3 squared divided by, this ratio reduces to 1 over 9. So I have a 9 in the denominator. All of that is equal to 1. Now that I have it in standard form, we can use the set of equations that were given on our formula sheets. Notice here, our bigger number is 9, which is underneath the y. So we have a major axis that is vertical. We'll be using this set of equations. So in this case, I'm going to use my sticky note to cover up the other set. Let's start with our center. Our center is going to be a negative 1 since this is positive. And since we have a negative in our equation, this will be a negative 1. Our k will be 3 since the negative is part of the equation that we want. So our center is going to be negative 1, 3. Our a squared is going to be equal to 9, which means that a is equal to 3. Our b squared is equal to 5, which means b is equal to the square root of 5. We can solve for c using this equation here. So I'm going to do c squared equals a squared minus b squared, which is equal to 9 minus 5, which is 4. So c is going to be equal to 2. Since we've already listed our center, we can go ahead and go on to our foci, which is the next one we want. So when I go to my foci formula, I'll be using these. Remember, this is going to be our h, and this will be our k. So let's go ahead and use our formula. So foci, which is f, is going to be equal to our h, which is negative 1, comma, k, which is going to be 3, plus c, which is 2. The other one is going to be h, which is negative 1, k, which is 3, minus c, which is 2. And I'm going to simplify both of these. So the first one here is going to be -1, 5, and -1, +1. These will be my foci. For the vertices, you'll be using the equation here. So I'm going to go ahead and denote that V, and we have an H, which is -1, a K, which is 3, plus we're going to be adding A, which is +3. The other vertice is going to be H, which is -1, K, which is 3, and then we're going to subtract the A, which is 3, so -3. Let's simplify these. So here you should get -1, 6, and -1, 0. Okay. Here are going to be our foci, and here will be the vertices. Our center is there. Let's go ahead and solve for our minor points just to have it complete. So our minor points, I'll put them here. And we're going to go ahead and use H, which is -1, plus B. Well, here we have B equaling the square root of 5. So I'm going to put plus the square root of 5, comma, K. And K, remember, is 3. Our other point is going to be H, which is -1, minus the square root of 5, comma, K, which is 3. These are going to be our minor points. Let's go ahead and graph this one. Remember, in this case, we always want to start with the center. Here, the center is going to be -1 and then up 3. 1, 2, 3. This is my center. When I'm looking at these values here, I'm going to say, well, my 9 is underneath the y, which means I want to go in the y direction by the square root of 9. Or in other words, 3 units up, 1, 2, 3, and 3 units down, 1, 2, 3. These will be our major vertice points. If I look here, I can see -1, 0, and -1, +6. This works. For our minor points, we don't know what the square root of 5 actually is, so I'm just going to go ahead and plug that into the calculator. The square root of 5 is going to be approximately 2.2. So I'm going to write that down here, approximately 2.2. So from the center, I'm going to go 2.2 going forward and 2.2 going back. Okay. So now I'm just going to go ahead and connect everything together and draw my ellipse. That's what it will look like. Number 5. Number 5 says to give the equation of the ellipse in a standard form. Now we're given a center, and we're given a focus, and we're given a vertice. So the first thing you want to do is notice that the center is always going to be our H and K. So I'm going to label those 2 points. I'm also going to graph it here on the side. So I'm going to say +1 and then up 3. 1, 2, 3. Notice that our focus is at -2, 3. So let's go ahead and draw where that is here. Back 2 and then up 3. 1, 2, 3. I'm going to label this point F. I'm going to go ahead and label this one C, just so I have it complete. And then we have a vertex that's at 5, 3. So 1, 2, 3, 4, 5, and then up 3, 1, 2, 3. Here's going to be our vertex. If you remember, our major axis is going to be along the foci, the center, and the vertice. So I know automatically that we have a major horizontal axis. So the first thing I'm going to do here is go ahead and eliminate my vertical major axis equations. Now what I want to do is find out what the distance is between the center and the foci. Now, the distance between the center and the foci is not that hard to know. It is actually really easy when you have your equations. So if we have our foci, which is here, notice over here we also have H and K. So the only thing that's different is our C value. So I can see that the distance between our center and our focus is going to be a value of c. So here all I have to do is count the difference. Well, there's 1, 2, 3. Here c is equal to 3. To know what the distance is between the center and the vertices, we want to go to the vertice equation. Notice that our h and our k, which stands for our center, and the only other variable listed here is a. So the distance from our center to our vertice is going to be called a. And here the distance is going to be 1, 2, 3, 4. So here a is equal to 4. So now that I know this information, what I'm going to go ahead and do is start off with my basic graph that looks like this. Okay, I'm going to go ahead and put x minus h squared divided by a squared plus y minus k squared divided by b squared. All of that is equal to 1. Don't forget to include 1. That's something that is often overlooked. Okay, so let's go ahead and plug it in. H is already given to be 1 and k is already given to be 3. We have our a, so we can easily find our a squared. But notice that we have c and we need to solve for b. So go back to your equations here and plug it in. I'm going to use c squared is equal to a squared minus b squared. C is going to be 3, so here I'm going to have 9 is equal to, a is 4, so 4 squared is 16 minus b squared. Rearrange your terms and you get b squared is equal to 16 minus 9, which is 7. So b is equal to the square root of 7. Now in this particular case, we only need to know what b squared is, not what actual b is. So this is going to be sufficient. Let's just plug everything else in. So x minus h is going to be equal to 1 squared over a squared. Well, a squared is going to be 16. Plus y minus k, and k is equal to 3. So y minus 3 squared divided by b squared. B squared is going to equal to 7. All of that is equal to 1. Just bring down the 1. All right, that concludes your notes for 10.1. Let me know if you have any questions.